So now we'll introduce our second speaker. It's Kyle Titlow. Titlow is a postgraduate geospatial analyst fellow in the Office of Spatial Analysis and Visualization at the Bureau of Transportation Statistics at USDOT, supported by the Oak Ridge Institute for Science and Education. Kyle's been at BTS since June 2018, when he completed his master's degree in geography at the University of Arizona in Tucson. He works on projects that collect, analyze, and visualize big data, namely GPS data from vehicles, to better understand the United States national intermodal transportation system and its spatial extents. He is interested in learning more about the role of visualization, especially in web cartography and app development, and the effective communication of transportation data analysis.
Thank you. All right, I'm going to be presenting the interactive pedestrian fatality web application, which is a web map that was built in-house to showcase the results from some of our ongoing work at DOT. So I'm going to begin with a quick background on the data being presented in this app, the intended role as well as the audience, and assumptions that went into the construction of the app, and then I'm going to spend the majority going through an inventory of some of the elements that I included, the thoughts. So this app emerged out of the Safety Data Initiative at the USDOT. This is an effort to harness data in kind of a three-pronged approach. First one, to use data to identify safety problems in the transportation network, then use analysis and advanced analytic techniques with these data sets to better analyze these safety concerns, and then as a last step, build tools to help policymakers, those involved with these issues, make appropriate decisions. So one topic that was explored was how pedestrian safety is influenced by characteristics of the transportation system and the built environment, looking at neighborhood scales across the entire United States. Analysts in our policy office at USDOT built an advanced econometric model that looked at estimating pedestrian fatality risk for all neighborhoods, at least at the census tract level, in the US, with the output statistic being a predicted number of yearly fatalities per 100,000 people. Data from the model came from a number of sources, including the Highway Administration, Transportation Safety Administration, the EPA, Census Bureau, and this was published in a report. I have some links to it at the end. But I'm going to focus primarily on the final step of this project, which was to develop a clear, compelling visualization of this model's results to serve as a decision support tool for policymakers interested in pedestrian safety. We decided to make a web map primarily because the results are already intended at a geographic scale, a census tract, nationwide scale, and we were also let us use the app is easily constructed using some of the Esri tools that are available to us, and is hosted publicly on the USDOT map server. And some of the considerations that went into this map, and then I will highlight how some of these show up in the app itself, were to accentuate neighborhoods with the highest risk, allow users to quickly navigate across the country, include other geographic layers that would be of relevance to policymakers, like metropolitan planning organizations and legislative districts, provide links to the project documentation for those who are interested in reading the full paper, and then also show the underlying road network and input variables. The tool's been live since January 2019. The link is here. It'll be included in my presentation as well. But the tool itself looks something like this when you open it up, Pedestrian Fatality Risk Map. And I'm going to talk about specifically 7 elements that were included in this and the thought process that went into them relative to the goals that were outlined. And I'm going to go through each one, as well as we'll each show a kind of short video clip of this element. So the first one is a splash screen. When you first open the app, you're brought to this image. It contains the project title, information, the DOT logo. It also outlines the history of the app, the history of the model, where it was coming from, the Safety Data Initiative, some of the symbology issues that are in place, as well as it discusses the tools that I'm going to showcase here as well. But this is primarily for users, that way you're informed heading in, and at the bottom we have a link to the Data Initiative page, which contains further links to the actual paper on which this study was based. So one of the first and most important elements were these supplementary spatial layers, and these are geographic units that we believe to be important to potential users of this tool. And so those can be seen by opening up on the app, opening up the Legend tab on the side. This is where those are shown. When you're zoomed into a level where those layers are visible, they appear there on the left. At this scale, only a few of them are being shown, but the inventory of potential layers are shown here, including metropolitan planning organizations, congressional districts, urbanized areas, statistical areas. The legend remains visible throughout there on the left, indicating the risk level. But navigating back over towards the actual layers, they can be toggled on or off to help showcase patterns within different geographic units. Each of these is tied to a spatial data service from our in-house GIS, USDOT's GIS layer database, the National Transportation Atlas database. So these are services being loaded through a link. And so here are just different geographic units that might be represented by policymakers interested in solving pedestrian issues. So first you saw the metropolitan planning organizations, congressional districts. We can also see urbanized areas. We can zoom in and see metropolitan areas. They're each colored in a color that contrasts with that underlying layer, which is the results layer. And then zooming in, you can also add things like counties and the states, depending on which area is of interest to you. But what's actually neat is another tool that actually adds a bit of teeth to these layers themselves. And how this works is this is intended, again, for policymakers interested in the results of this model at their local level. They can go to this tool, we call it the Zoom to Region tool, a little push point here at the top. And what this does is it will automatically shift the map, pan the map to a geographic area of interest, which are all referenced to layers contained in our GIS database. So when it first comes up, you see states, urbanized areas, Native American lands. And within the states, once a state is selected, and all of the states are here, including the territories, this tool was built for a separate web app that we have in our office, but in this case was also usable in this instance. We then see, for that state, Montana selected here, we have 6 other different units that can be selected from. Counties, congressional districts, MPOs, upper state, lower state legislature districts, and zip codes of various scales here. So once you've decided which one you want, you go to the MPOs, you can make a selection. So say you're from the Missoula MPO in Montana, and then you hit apply. It takes this tool a few seconds to run because it's referencing the full database of geographies for the United States. But once it pulls up, the image will zoom in, and there we go. If this was your MPO, you would have the census tracts pertaining to your area here. And just to show you that it is indeed, we go over to our layers layer, the layers tab. There we go. We see that polygon there matches up. So in this case, there you go. In this case, it looks pretty good. We see that the tracts here are all relatively low pedestrian risk. But we can also go take a look at other geographic areas as well. One that definitely would be of interest, especially in rural areas, congressional districts. So you go in, identify your congressional district, and then again, the tool thinks for a second and then takes you to the area that you are interested in. And just like before, where we were looking at the other layers that were available, once you're zoomed in, you can take a look at the other geographic areas that may pertain. So if you're the congressman from this district in Mississippi, you can see which MPOs might also be involved in some kind of project. You can also see the urbanized areas as well as the rural counties are all labeled relatively clearly for you. Areas that are doing well, areas that are doing poor are fairly obvious to the user, which is really nice. This was a tool that was added in afterwards, specifically with keeping the kind of potential users in mind. And then one of the smallest units that's available is even down to the zip code. So here in the District of Columbia, we can zoom to, this is up in the Columbia Heights, Mount Pleasant part of DC, and you can see results all the way down to within an individual zip code. And then going back out again, we see urbanized areas. In the case of the Native American lands, they are all included in one drop-down list. And you can zoom through, scroll through the list, make a selection, and the tool will head to that area. So there's a lot of power in this tool, and is probably the most helpful element to making these data available to potential users. So next is the symbology. The symbology was carefully chosen in order to accentuate the areas of highest pedestrian risk according to this model. Now we show the actual statistic. The actual output of the model was predicted daily fatalities, but the legend itself doesn't actually reference the specific fatality numbers within the actual values themselves. Instead, we reclassified the value for individual tracts into the percentiles, and then decided to highlight the top two, above 80th percentile and above 90th percentile. And so again, this really helps to accentuate parts of the country where this model, according to its input parameters, has decided are the areas at greatest risk for pedestrian safety. And generally speaking, the patterns we saw that resulted spatially were the south and the west, zooming in both in urban areas and rural areas, tended to show risk based on this model. Areas in the south, generally towards the south, a number of the highest scoring, most dangerous areas for pedestrians tended to be in southern areas, but also in Native American reservations. So one reason that tool element of being able to zoom to these areas of interest would be of use to a user. And then, once you zoom in close enough, we added two other features related to the other variables that were included in the model. There were many independent variables included, but here we included a selection of variables that contributed to the model that might also be of interest for those looking to study issues of pedestrian safety at the local level. So along with the actual value, the predicted number of fatalities, the census tract number, we also get things like whether it's an urban or rural tract. We get things like how many people are walking to work, how many people are taking transit to work, intersection density. These are various variables that came from different sources that were included, as well as a congressional district there at the end. So this one is pretty intuitive. The way the map is set up, the boxes are you're only able to click on a track and have it show these values when you've zoomed in to a local level. So using the search box at the top, which is an alternative way to reach places other than the zoom tool that we showed earlier. But you can zoom into an area, take a look at the individual tract, you see the values for that tract, other things that might have contributed to why the score was higher, other elements of the transportation environment that could be fixed or adjusted in certain ways, or other larger socioeconomic issues that may have contributed to the model value and congressional district. Anything that might have been of use. And so you can also, at the very bottom of this tool, in a second we'll show zooming. You can actually zoom down to the individual layer and look really at the block level. And depending on which base map you have visible, that will show the road network that underlies that tract. And so similar to the zoom to tool we saw earlier, there's an additional tool that is associated with these other values. That's very nice. And this is really good at looking at some of those other variables that might have explained the high or low fatality risk in certain neighborhoods. And so what these are a series of filter tools. And you'll see them here. We're looking at Birmingham, Alabama in this case, which is a city with relatively high pedestrian fatality risk. And if you reach the tool by clicking on the small funnel button at the top, and then for each of these seven filters here is tied to one of the variables that was seen in those click boxes. And so these were variables that our team decided would be relevant, be of interest to people. And you notice there the same variables that you see there on the left are the same ones you see there on the right. And so if you were only interested in seeing those tracks highlighted, which corresponded to different values, you'd be able to do that. So for one, if you wanted to see, where are the highest risk tracks in there you go. It only shows those that are visible once you're zoomed in within the map. But if you zoom out of the city or go into rural areas, you see there's not quite as much. But you can do the same with any of the other categories, percentile values associated with the model output. So with the way this is colored, the lowest, the neighborhoods with the lower risk don't show up quite as clearly as those with the highest risk, which was, as mentioned, the intention of the tool. We can also look at just urban or rural areas. And then we get into some of the other variables which may not be quite as intuitive to, or to the average user. You may not be as familiar with what common values are for these. And so underneath each of those boxes, it's kind of hidden up on this screen here, but I provided the range of values. So that way, if you're not sure, what do I even put in this box? What makes sense as a high or low range? That's provided there. At the same time, if you want to know values and areas that you're looking for, you're also clicking on the boxes there will reveal them. And so that works for percent of people who walk to work. The same is true with people taking transit, which is interesting. We also have transit to work. In these cases, those values are a little, maybe slightly more intuitive to the user, but intersection density is one that is definitely not going to have someone, or we may not know exactly what value they're looking for. So zooming into this tract, we can see that there's a density of 4 intersections per mile, and that was one of the variables in the original model that was included in the final estimator. But income and average daily population are other examples of things that can be done with this. And then one last element I'll talk about are the adjustable base maps. And these are reached in the top right corner with these kind of 4 square icon. And each of these are included within the Esri app product, but each of these highlights a different element of the different locations that somebody might be using this tool. And so in this case, since this model is looking at pedestrian fatalities, and road safety is such a large component of that, the base maps that are oriented towards streets, like OpenStreetMap, and the streets base map that's included, make more sense. Although, as you'll see here, I'm going to zoom into the Native American reservation in South Dakota. This is, again, I mentioned earlier, a type of geography that tended to show higher values from this model. This might be a case where knowing the terrain or some other element of the natural environment could be of use to somebody who is studying this. Why am I seeing the values that I am in these places? But this is, again, another customizable element for those users who are trying to get as much as they can out of this tool, draw as much information as would be useful. But and here in a second, the tool will move back to Baton Rouge as a kind of one of the many southern cities that showed higher values with the model. And this is a case, again, we have the satellite imagery there if that would be useful, but click out something like OpenStreetMap can provide you with the street network underlying these different neighborhoods. And as you know, loading any kind of streets layer, nationwide streets layer, especially something that would be relevant for individual neighborhoods, would be an immense, would be quite an ask of the program to have to load each time. So using these base maps helps us add more information to this tool without overloading it and allowing it to be useful, maximum utility. So those are the main elements. Those went through a number of iterations where we added a tool and we decided to add something later because it might have been more or less useful to somebody who'd be using this. There's plenty more that we could do. I can't speak very much to the model itself, so if you have any questions, I can direct you to Paul, who's here from the policy office, who can maybe help you out with that. But here are some links to the map itself, as well as the Safety Data Initiative and some of our other links here. The BTS is where I'm based, and our National Transportation Atlas database contains free GIS layers. Any one that you saw in that map is available here in some form or another. And at the very bottom is the link to the paper, if you want to check it out. Thank you.